Okay, question 8. A ping-pong ball is a spherical shell for which the moment of inertia is given by 2/3 mr squared. A particular ping-pong ball is rolling without slipping along the floor at a speed of 1 meters per second. So v equals 1.0 meters per second. Its mass is that many kilograms, and its radius is that many meters. What is the total kinetic energy, rotational plus linear, of the ball as it rolls in millijoules? Okay, and there's some millijoules. Okay, so let's start with the linear, because that's the easy one. The kinetic energy is equal to 1/2 mv squared. Let me just work this out. It's a half times its mass is 0.0027 kilograms times 1 squared. Plugging that into my calculator, I get that its linear kinetic energy is 0.00135 joules. So that's equal to, in millijoules, we multiply by 1,000. So 1, 2, 3, 1.35 millijoules. Okay, so that's linear. Now the rolling, we're going to have to say that it's rolling without slipping. That has a condition. That is when the axle is moving the same speed as the tangential speed of the edge of the wheel relative to the axle. So, saying that again, the v equals omega times r is the condition there. So, we know v and we know r, so we can solve for omega. Omega is equal to v divided by r. We know the equation for rotational kinetic energy. Rotational. Let's call that k with little sub r. It's equal to 1/2 I omega squared. So that is equal to 1/2 times the moment of inertia is still on the screen up there to the right, so it's 2/3 m times r squared times omega squared. Omega comes from above, v over r, all squared. So let's simplify that. What will happen is the 2's will cancel, the r squareds will cancel, and we will have 1/3 times m on the top times v squared. So instead of 1/2 mv squared, it's 1/3 mv squared. That's kind of interesting. Plugging it into my calculator, I got 0.90 millijoules. Okay. And so the total is equal to 1.35 plus 0.90. So I get is equal to, let's type it to my calculator, 1.35 plus 0.9, 2.25. 2.25 millijoules. So that's approximately equal to 2.3. So looking up at our answers, the answer is A.